Please note that this is a sponsored event and any opinions expressed are those of the presenters and do not necessarily reflect the views of ASCE. ASCE also asks that presenters and participants refrain from discussions surrounding competitors and pricings of products and services. And now it is my pleasure to welcome you to Water Systems and HDPE Projects. I'm thrilled to welcome back our valued partners for the fifth consecutive year of providing high quality HDPE sponsored webinars with ASCE. This is the second of 4 exciting webinars in the 2025 series, generously brought to you by the Alliance for PE Pipe, Modern Polymer Pipe and Extrusions, and Core in Maine. Each webinar in this dynamic series will deliver 75 minutes of invaluable content. And now I'll turn things over to your moderator, Alan Ambler, President, AM Trenchless. Welcome, Alan.
Thank you very much, Robin. It's hard to believe that it's been that many years, but we certainly love to share all sorts of information about HDPE, and glad that everybody's here with us. So here, everybody see my screen just fine. Water systems and HDPE projects is what we're talking about today. So the Alliance for PE Pipe has a lot of different members that fund our actions and opportunities to bring you educational information such as what we're providing now, and then also what you can see on our YouTube channel as well. So we are very thankful for all of these members to be able to help fund the Alliance's efforts to make sure that we bring you great information for educational use of polyethylene for municipalities and that function. We are very active on social media, as you see here. So any of these platforms, if you like those platforms, certainly check us out. You'll be able to see all the ongoings of HDPE as it's being installed, or discussions for construction or other things that are happening within the HDPE world. We're fairly busy. Lots of different stuff going on with the Alliance for PE Pipe. We try as hard as we can to be able to get out and connect with you to the best of our ability. So here's some primary examples for us as well. We are looking at all sorts of different road shows, trade shows, and webinars to be able to be in front of you and talking about all things high-density polyethylene. So if you can attend any of these, we'd be happy to talk to you about your project and anything else that you've got going on for it. Our next, one of our next videos, video day with Ask Me Anything is coming up May 6th. So that is exactly what it sounds like. You can ask us any question that you possibly want. If you've participated in an Alliance for PE Pipe webinar in the future, you know we have a primary session that goes through where we talk about the content of the day, but behind the scenes, there's lots of questions that are asked of our bench and our people that are experts behind the scenes to be able to answer those questions. And this version, this Ask Me Anything, is right there just specifically for that thing. So type in your question. We'll bring up all of our resources, well over 100 gig of videos and images to be able to show you what your answer to your question is. And this is happening May 6th, so definitely join us for that function in that way. We do have lots of free resources for you. So there's an engineer's package on our website at pepipe.org. That includes typical details. It includes the PPI handbook on polyethylene pipe. It includes all sorts of specifications and other things that are there for you. We'd be happy to help you edit your specifications as well. You just got to email us and talk to us about it. Provide lots of project assistance. What that looks like basically is what you're looking at here, a Zoom meeting one-on-one with you and your group to be able to look through your project and your specific needs to talk about those engineering items that are related to your particular project as well. So if Taylor and Steve can come on and tell us a little bit about our sponsors today. Taylor, let us know what it is that Modern Group does and how they can help our audience.
Yeah, thank you. Thanks, Alan. Thanks for having me on. I'll be quick because I know you guys have a lot of slides to go through. But Modern Polymer Pipe and Extrusion is an HDPE manufacturer based out of Houston, Texas, right in Pasadena. And we have two locations in Beaumont and West Texas, and we produce 2 to 24-inch pipe HDPE, and we try to focus a lot on coils because we think that's where a lot of the industry is headed. And 2 4-inch, and then we just added our new 6-inch coil that we got in from Europe last month. So we're excited about things to come. We think that there's a lot of opportunities in the HDPE space right now. So we look forward to hearing about today's seminar. Thanks again.
Awesome. How much pipe can you coil up on a coil like that? Is that 500 feet, or is that what we're looking at for installation?
Yeah, 500, 800, and 1,000 feet coils, and on the 6-inch up to 1,000 feet.
Awesome. Awesome. So any HDD project that you got going on out there, if you need that pipe size and diameter, they'll ship you a coil just right there for it. You make a straight shot and you're good to go, right, Taylor?
Yes, sir. That's it. Thanks so much, Alan.
Absolutely. Steve?
Yeah, thanks, Alan. Yeah, Core & Main is a national distributor of underground piping products, one of the largest in the nation, and I'm part of our fusible HDPE division, and we support our national footprint of 400 branches across the United States on the fusible HDPE side. So that includes fusion rental equipment, obviously the pipe and the fittings, and fusion tech services and training. So that's what my division of Core & Main does for our larger distribution network.
Awesome. We are so lucky to have you here with us. You're also one of our speakers for this program as well. If you want to come on and talk to us a little bit here about you and Milford and what it does that Milford does and provides for everybody. And then, talk to us about what you're going to talk about today.
Sounds good. Thank you, Alan. Yeah, so my name is Eric Elizondo. I work for Milford Pipe and Supply. We are a brand underneath the Wind Supply Company, which is also a nationwide distributor for pipe valves and fittings for municipal application. Similar to Steve, I work in the municipal side for HDPE application, so helping engineers, municipalities learn and adopt HDPE into their systems more accurately, as well as helping with, of course, all the training, the fusion, and any other fittings to, essentially connect HDPE to any type of legacy systems. And help teach that training across the nation to the other wind supply stores to help endeavor the growth of HDPE in the municipal realm.
Awesome. So we got a pretty active bench as well for everybody today. So that bench, as I talked about before, is any question that you have, type into the Q&A, and all of these experts will be right there to be able to help answer your particular questions. So don't hesitate to ask those questions the second that they pop up in your mind. We've got people live behind the scenes to be able to answer all of your questions in that manner. Take a screenshot here. This is how you get in contact with us. We do love to talk about polyethylene pipe and also different installation methods for polyethylene pipe. So we'd be more than happy to talk to you about your specific project and be able to address any concerns or questions that you have. So here's how you get a hold of us and get in contact with us, and we're very happy to talk to you about your particular problem. So where are we with an industry-wide? AWWA Buried No Longer came out in 2012. It shows that we need at least $1 trillion over the next 25 years. We fast forward from 2012 to now, and this number hasn't abated. It's still pretty significant as to what is necessary to be able to make your program funded, to go out and proactively replace that existing infrastructure as we see it. There is a water main break every 2 minutes. That's a lot. That's not like 9 a.m. on a Tuesday after you finish your coffee. These things happen at Christmas morning, during the Super Bowl, that type of thing. So there's all sorts of different emergency response that happens at the municipality to go out there and fix that infrastructure as we're seeing it. We want to try to move from a reactive progression to a proactive progression, to go out and try to proactively replace this pipe. HDPE can be used quite a lot in order to be able to help you move to that progression as well. So everybody needs more tools, not less, to be able to try to replace our infrastructure as we see it. And the Alliance tries as hard as we can to be able to provide you with different elements to be able to make sure that that happens. It is a leak-free pipe. That joint, when we fuse that pipe together, albeit butt fusion or electrofusion or some other type of fusion, that joint is as strong, if not stronger, than the pipe itself. And that's part of melting that resin to certain temperatures, allowing the molecules to flow across that interface, and then allowing it to cool. And that joint is as strong, if not stronger, than the pipe itself. It also provides that leak-free system that we're looking at. There's a very significant amount of water loss in our national average of systems, and then there's unfortunately not a lot of cost associated with it because we're undervaluing that particular provision of potable water in that manner. So even though there's a significant amount of water loss, sometimes we're not tracking it in the best of our ability, and then we're not truly looking at the potential cost for it. How do we look at it from a distribution and collection? So this is DNC that we're looking at it. Based on all of the maps that we have GIS records, we have as-builts, we have other things that allow us to try to look into our system and manage and operate our system as we look through here. And here's just a few examples for you as to how we start to pull all of this information together. So a geographical information system, a GIS system, happens to have data associated with mapping elements. So we put those two together, and then now we're finding all of our line work, which is our pumps and our pipes and all the other things of that nature. And then we are merging those things together to be able to provide us with the information that is necessary to go out and maintain a system, and then also start to design a rehabilitation project. So our distribution system has two components. Not only is there a reaction effort when we start to fix a break, but there's also that quality of the water that we're looking at inside the distribution system itself. So sometimes that water, if not used, can get a little old, or other contaminants can be in that process, especially if we have corrosive pipes, such as cast iron or ductile iron or other metallic type pipes for us. And what you're seeing here happens to be a unidirectional flushing program, as to which we're focusing the valves and the flow within the pipe system itself to be able to purge that pipe system of any contaminants. Most people simply wouldn't consume water like this, so they'd allow it to flush. But with a unidirectional flushing program, where we're actually focusing as opposed to reactionary flushing, when we could stir up some of the contaminants in that manner. So what are we looking at for the main lines? We go from main lines all the way to service connections, and in between, we really want that pressurized pipe to be able to provide design pressure that allows us to operate the system at that particular pressure. We want to be able to provide for firefighting in its largest demand period. We do want a life expectancy of that 100+ years that we're going for. And then also in parts of the country, we have frost line. So we typically want that to be below the frost line. Most of these main lines are obviously located within a road right of way, in which case we have to make sure that it's protected and then also free and clear of third-party utility conflicts. So Steve, you came on. Did you want to add something to us here? What we're taking a look at here is a failure of a potable water main line itself. Obviously, this has a lot of pressure coming out and can do quite a bit of stuff to whatever surrounds that pipeline. And this is one of those emergency repairs that I was talking about. You spend a significant amount of time, Steve, in the operations and distribution and collection side to be able to facilitate repairs and then also installation of new pipe. So I'm going to hand it over to you now, and we'll keep talking about distribution systems.
Right. Thank you, Alan. Yeah, so, as a waterworks distribution company, we're the guys you call when this happens, to put a repair band on that. The nice thing about polyethylene, though, is this kind of thing just rarely happens, because we're not, this is probably a corrosion issue over time, or a ground shifting issue that opened up this catastrophic leak. And it's just the kind of thing that really doesn't happen very often in the waterworks or in the polyethylene world, because things like that are typically on if that was in a gas main where they already use polyethylene, medium density polyethylene, those things are all on the news. These are fairly rare in the water industry. So
Thankfully for that, absolutely.
yes.
So we're got some case studies as well, Steve. There's a bit more meat that comes for you for the presentation itself, but I think we're going to go look for Eric right now to talk us about this Albuquerque water main project that he's been working on as well. So we're certainly interspersing some of the case studies with all the other information.
Yeah, thanks, Alan. So, yeah, I wanted to kind of discuss the Tuhajali project that we are currently working on in New Mexico. We're right at the end of this, getting this completely put in the ground and buried and in service and ready to go. It's been something that's been in the works for the last year or so now, but kind of just wanted to visit this project because of the impact that it's having, as well as the diversity of the HDPE being used and how they were using it to accomplish the goal at hand here. So for those of you who don't know, Tuhajali is a small Navajo reservation on the outskirts out there in New Mexico, near Albuquerque. And they've been struggling for to have clean water for quite some time now. As you can see, by the photo there, this is a sample of the water that they have been having distributed out to their area. And little fact, 30% of that population lives without running water in their homes, right? Meaning they need to go to wells, they need to bring in water from elsewhere. But 30% of that population did not have water regularly running into their houses like we do on a day-to-day basis. I don't know about y'all, but just considering what that would be like would have a huge impact on our own independent day-to-day lives, right? And so the reason we want to talk about this was HDPE ended up becoming the solution for this small nation who's struggling for water. The county commissioner here made a huge push. They had a lot of issues, obviously, with land easements, dealing between the municipalities and the nations. And she made a huge push to go ahead and get this pushed through so that they can get some type of water line put into service for these people, which was actually ended up being done in 2020. Is when she pushed for it. The project ended up going off at the very end of 2023. All through last year, it was a project in the works and has been wrapping up the beginning of this year as well. But part of the problem was figuring out how to get the water from so far away to where it needed to go at the best overall cost, without having to worry about too many changes in materials, and obviously the differences in elevation as well from the origination to the ending point, right? So from the beginning, we actually had Sauter and Millers and Associates Engineering hop onto one of these presentations and hear about HDPE and all the things that we talk about, about HDPE, and it sparked an idea about attacking this problem at hand utilizing HDPE. At that time, I believe that was back in like 2022 when they reached out to PE Alliance and started getting some more information and kind of building a solution to the problem at hand that they would then go and present as the plan for it, right? So they hopped on this. We talked about HDPE and how to use it and how to integrate it into the system, and came up with a plan to go ahead and install 7.7 miles of water line using HDPE, connecting to the Albuquerque County Water Utility Authority and taking that all the way out to Tuhajali. Obviously, there was all the back end stuff to get the leasing done, to get all the appropriate you know, permissions done as well. So that was something that then happened after they had the solution. The project came out, you know, for the world, like I said, in the end of 2023. Myself and my team in New Mexico went and partnered up with AUI out in that area to figure out how to help them accomplish this and how to get obviously the best overall solution and pricing for this to, you know, save, you know, anywhere we could. AUI had done some projects in the past, but something like this was just a little bit different than some of the things they've done before. So utilizing the training that we have to help them learn, you know, the water side of it all and help them learn how to install it appropriately was something that Milford and us teamed up on. You know, again, in this project, there was DR7, DR9, DR11, and DR17. And for those of you who don't know what that is, it's basically a thickness and wall of piping with a different pressure rating. And the reason for the difference in the pressure, the different DRs in this project was to accommodate, again, for the elevations utilized in here to maximize the flow. The great thing about HDPE is that even with different DRs, you can fuse them together and they work like one consistent monolithic system as HDPE is intended to do, right? Between the beginning of the Solder and Miller Associates to the PE professionals to Milford, all the way through to the actual installer, it was something that, you know, there was an idea, a concept in mind in order to achieve this. And through the help of everybody involved, everybody on this webinar, we were able to get that installed. So I see a question from Hector. I will go ahead and answer that live. But it is possible to butt fuse different DRs. So the standard rule of thumb is to butt fuse either up or down 2 DRs from the DR that you are transitioning from.
All right. I was going to comment on that too, Eric. Absolutely. Thank you very much for clarifying. Our audience is always astute, and they're always right there to be able to try to help us with this good information. And I'm so glad it shows that you're paying attention. That's exactly what we want, is for you to be able to pay attention to it. So we're going to move now into main lines and open cut. And what is it that we look for through this open cut installation of the pipe itself? So Steve, you want to take over and tell us about open cut?
Well, so it looked like from Eric's pictures that most of his project was open cut. That's just the standard way to put in most pipelines in the industry, whether it was polyethylene or something else. I think we run into we kind of get into a rut where everybody looks at HDPE just for directional drilling because it's about the only product you can use. But it works great in open cut. You can thin down the trench and not have anybody in the trench when you go to rope it in the trench. So it's a big part of the future for HDPE is just to put it in like you do other pipeline systems. But like I say, one of the nicer things is you can narrow the trench because you don't have to have a trench box necessarily at all the points when you're digging the trench because of the flexibility of the product.
We're
So
maximizing productivity here, absolutely. So by not having anybody in the excavation, we're simply being able to take advantage of that long fused run and then maximizing that productivity. You're absolutely right, Steve.
yeah, there's a backhoe that just is sitting there opening up trench. They're not stopping every 20 feet to lower a piece of pipe and home a bell. So the design really isn't too difficult when it's exactly like other products that you've designed in the past. We have the design manuals for polyethylene M55, and really in most cases there's not a lot of extra work you need to do to figure out compaction and things like that because there's a design window that allows you to install pretty much like you do for, design like you do for any other piping product that you're used to using in the waterworks industry.
Now we're seeing a video where they're putting select material on top of the excavation that they just put through there. This is what happens in real life. This is exactly what we do to try to put that 1 foot of compactable material on top of this, and they'll come back through and compact that material as we go through. It is a flexible pipe material, so it is installed exactly the same way as PVC and ductile, because those are considered to be flexible pipe materials as well with regard to the excavation and the trench that surrounds it. But you could see we're able to put it around this S curve and eliminate some of the bends that would otherwise be necessary or fittings by taking advantage of that allowable bending radius of HDPE that we have. Um,
Hey, Alan, on that
yeah.
last, we got a question in the Q&A. It's a great question. We get it from time to time. I'm hoping you can address it head on. If you're not going to have someone in the trench, how do you ensure proper compaction?
So, mechanisms to be able to ensure proper compaction, this same excavator that we're looking at, they can take the bucket off of the front and then have some type of a tapping or a compacting tool on top of this excavator to be able to go through and make sure that you get that necessary compaction as we come through. So, I will say the pipe itself, the stiffness of the pipe works with the stiffness of the soil to be able to deflect those loads as we come around through this process. When we're outside of the design window of that DR7 to DR21, 25-foot deep, then we might want to be more concerned about the actual installation and making sure that we have proper soil that surrounds a much thinner wall pipe through that process. But there are tools, construction tools that are available to be able to make sure that you get that necessary compaction as we come through. Most of the compaction isn't necessarily for the pipe's health. It's going to be for the things that are on top of that pipe to be able to make sure that we don't settle flexible asphalts and other things of that nature. So great question. That's another function of having that parallel track here. Eric, you got something to add?
No, I'm just gonna go ahead and get on to the next slide.
I do have
Absolutely.
something to add on the last slide. The one difference between polyethylene and other products is, in that case, we don't need to put concrete backing behind any of the fittings because it's a completely fused and restrained system. So you can eliminate all the concrete backing that you have, that you typically design in a PVC or a ductile system, because those concrete kickers are there to keep the bell and spigots together, right? Well, we don't have bell and spigots, so you can eliminate all that extra concrete backing, which can save quite a bit of money and certainly time.
Yeah, that's a great point, Steve. Yeah, so I mean, kind of elaborate on what you're talking about with the differences in HDPE in regard to other materials. A lot of times, you know, when we start looking at connecting the legacy systems or using the legacy system products that have been used for forever, like valves, you know, a lot of times there's confusion on the connection to those materials. The cool thing about HDPE over the last, I don't know, 25 plus years at this point is the adoption of different types of fittings to be able to connect up to the legacy systems, allowing us to use all the same valves you would use in a standard PVC or ductile iron piping system. And so with the HDPE, you still have the same opportunity to use the exact same valves you would have used. You can still stick with your standard, you know, your standard expectation for those fittings. You know, they came out with the MJ adapter, which you see on the slide on there, that is connecting directly into the valving system, which has an internal stainless steel stiffener to help with expansion and contraction at that conjunction, and connects up and bolts up the same way that you would connect up and bolt up with a Megalux or traditional PVC or ductile iron, right?
And that creates a completely fully restrained system. So your MJ adapter is fused onto the pipe or the fitting, and then onto the next pipe and the next pipe. And then when you come to this mechanical joint connection, the restraint is those, in this case, those blue bolts. You would have to break those bolts to pull that apart. And so that makes it a fully restrained system using the MJ adapter.
So same thing when we're looking at hydrant. You know, typically on a standard system, you're branching off of the main line coming out with the gate valve, and then your hydrant assembly. You know, you can do the same thing using HDPE, as you can see in that middle photo there. It's HDPE branched off into a valve using MJ adapters, then branched off with additional HDPE to an MJ adapter connecting up to your fire hydrant assembly. So again, same thing. Just, HDPE has taken a long initiative on trying to make it easier to utilize this in your potable water systems or any distribution systems and collection systems as well, in order to integrate this in the system with little, little difficulty and or resistance.
Yeah, so this is the most common use of HDPE. You see this in conduit all over the country and on the gas side. But you can do main lines with the HDD, which is horizontal directional drilling. So this is just an alternative installation method. It is by far the most common use of HDPE. So open cut is the standard for legacy piping systems. There's absolutely no reason you can't do open cut with HDPE, but when you need to go under other utilities, crossing waterways, I think there's a highlight on this particular project later in the presentation. This happens to be a force main. You can install it by pulling it in and creating less, what I like to call construction destruction. You don't have to tear up this entire road and haul off all the spoils and haul back in all kinds of backfill. You can fuse this long run of pipe together on top of the ground and then pull it into place, avoiding a lot of that construction destruction, as I like to say.
Some fairly brilliant people in our industry said if you're going to use it for the hard stuff, let's use it for the easy stuff as well. So that's just part of it. Here's pipe bursting, which is the only trenchless technology rehabilitation method that can put back a larger OD pipe than what was there existing. And so pneumatic pipe bursting, which takes an impact hammer driven by compressed air, only uses HDPE through that process as it moves along. And we're just continuing to break that pipe to create a temporary soil cavity surrounding it and pull back the replacement pipe. So static pipe bursting can use definitely different pipe materials, but is just another way to be able to provide the force required to be able to do the bursting. Slip lining itself is another rehabilitation method for existing pipeline, as we're looking through here, and it functions in the same fashion. So we're essentially getting access to that pipe as we're putting new pipe within the existing pipeline. We're making sure that's clean, clear of obstructions through that process. And then we're just pulling that pipe, HDPE pipe, through that existing pipeline to be able to make sure that we can fit the brand new pipe to be able to do what we need to do with it. Now, if we take that slip lining and then put it on steroids, then we look at compressive fit slip lining. And so we're taking that pipe and we're actually, it's only done with HDPE. We're reducing the OD of that pipe through this die, as you're seeing here, temporarily. And then we're allowing that pipe to relax, and it'll forcibly push up against the ID of the pipe that we're slip lining through that. It's taking advantage of the viscoelastic behavior of HDPE in order to be able to provide this through. So, Steve, take it away.
Yeah, I'd like to point out that these last three installation methods, so pipe bursting, slip lining, and compressive fit, all take advantage of the fact that the utility already owns that right of way, right? There's a pipe already there. You don't have to go out and find a new right of way or a new spot to put this new pipe. You're basically rehabilitating an old pipe where you already own the right of way and upgrading it to the 21st century. So I think that's an important thing to realize on the advantages of utilizing those installation method technologies. And on the pipe bursting front, the target audience there is anything very fracturable. So we're talking brittle pipes like clay, cast iron are the target markets for pipe bursting. So thank you for going back there, Alan. So when we're building these projects, there's you're adding service connections when you put in a new water line or force main, and so over the years, all these things have been developed for polyethylene. They were originally developed in the gas industry. I mean, the gas industry, we basically are copying the products used in the gas industry since the 1980s, and so it's really not anything very new because the entire gas distribution industry has been using these products for 40 years. Now the sizes are getting larger for the water industry, so because obviously water is not as compressible as gas is, so our water mains are larger than our gas mains. So some of the larger diameters have been developed in the more recently, but the service connections, there's all kinds of different options. In this case, the gentleman, they have fused on they have electrofused on what looks to be a 6-inch lateral, and he's drilling the coupon out of the main line. Obviously, that's not a hot line, or he'd be getting really wet when he ends up cutting that cookie out. But all these things, these service connections are important on all those installation methods, because once you go through and replace the main line, you're going to have to come back and connect your services to the individual houses. And we have all the products, both fuse on and mechanical, to do that and accomplish that.
Yeah, I think that's a good point, Steve. On the next slide, it's kind of cool to see where, when we're talking about the different types of installation methods and we start talking about pipe bursting. I'm based out of San Antonio, down here in Texas, and SAWS has become a big user of HDPE in its systems. And pipe bursting is one of their favorites, right? There's obviously several different cost savings, like the trenching, the having to work on directions, and the safety precautions when you're going and replacing these lines or rehabilitating these lines. But along with that, the ability to replace a line and connect services to to your users, your citizens, as quickly as possible with doing something like a pipe bursting installation, just pulling it through, not having to open that trench, and all you have to worry about is reconnecting service lines, and how promptly and quickly you can go to it has been one of the biggest reasons SAWS has adopted it the way that they have. And like you said, there's the cool thing about the HDPE is that there are several different ways of connecting those service lines. You kind of touched on it a little bit. There's still just the standard mechanical versions that you see in the other materials. On the next slide, it'll show the electrofusion versions of that, and two different ones, right? So there's just the standard electrofusion with a threaded outlet to connect up the same way people have been doing it for as long as can be. And then on there you have a tapping tee. So the cool thing about that tapping tee, where you see him inserting that heater plate, is you can fuse that onto a live service line and then utilize the stainless steel hex head that's inside there to tap into that line while still in service after your service line is connected. Obviously, don't need to mess up there, but it's come a long way to be able to connect these and make it efficient and quick, so that not at the end of the day, not only are we saving money, but we're also servicing the people using this water lines appropriately.
Yeah, like Eric said, this is kind of an evolution. So on the left is a standard corp stop, which has been used for ductile iron jobs and tapping into ductile iron and PVC using a mechanical saddle. We find that a lot of municipalities that adopt polyethylene, they still want to keep their legacy clamp and coupling products in their corp stops, so they do, and then they evolve to this electrofusion saddle, but they still hang on to their corp. And then eventually they evolved to the tapping tee that is shown on the right-hand side. There's millions and millions of those in the ground in gas systems today and been operating for 30 to 40 years. So I've watched cities that start to adopt the pipe, and then they start to adopt absolutely everything. They kind of evolve through the process. City of Fort Wayne is a great example of that. They're using that tap tee on the right, and they weren't when they first adopted polyethylene, but they do today.
And the industry itself has changed in order to be able
Yeah.
to allow, any user that wants to put this to use their brass fittings. Sometimes it's not always clear as to why it is that we want to use brass fittings when we know, fusion really works well that way. But definitely is modified and morphed to be able to give us what we need. So we are furious with questions. Thank you so very much. We have well over 30 questions, and they're just continuing to go through it. You're paying attention. You are part of the program. Your questions make us better, and hopefully we're making you better through this process as well. So keep going, Steve. You're doing great, and we've got another 30 minutes to go thereabouts.
Just these are just more great examples of how you can use polyethylene in the standard way of laying an open cut pipeline. They're just they're roping the pipe into the trench. Obviously, those slip lining and directional drilling jobs are usually done in very highly congested areas, but when you're out in rural areas, you can get incredible production um, by fusing long lengths together and roping them into the trench, as you can see in these two pictures. So
This is another example of a municipality that decided to replace everything at once. So they're replacing the potable water main, they're replacing the gravity sewer, and we're simply taking advantage of that long fused run to be able to open up all of the earth at the same time. So there's certainly some convenience put through this, but obviously these residents are impacted by this process through that. But one of the benefits of that long fused run allows for maximized productivity, and we're simply not in front of the residents for that long as we go through. Here's some guidance from the Municipal Advisory Board. Steve, maybe you want to tell us about that.
Yeah, so the Municipal Advisory Board is a group of users of polyethylene, so municipalities and water departments that came up with some standards for, in particular, electrofusion, which is just another type of fusion. There's butt fusion, and then there's electrofusion that are used commonly in the polyethylene industry, and they're really the same, other than where the heat source is coming from. For electrofusion, the heat source is coming from um, heat-resistant wires that are built into the fitting, and we run a current through those wires, and that's the source of heat. Well, the municipal advisory board came up with some standards for installing these in the various sizes. And the reason they did that is because the manufacturers of these products all had their own standards. They were very similar. And this was true in the early days of the polyethylene pipe world, is each manufacturer had their own standard for fusing their pipe. And then eventually they got together and created an American standard for fusing pipe that they all agree on. This is the beginnings of that. And you can get your operators trained to these standards, and so they install these products properly. It's pretty straightforward. And again, each manufacturer has kind of varieties of this, but it's all the same. You got to have clean pipe. You need to mark your stab depth. You need to peel your pipe. We used to use the word scrape not too many years ago. We're getting away from that because what we need to do is actually remove a layer from the outside of the pipe where the fitting is going to be placed. It's just like you have to face pipe ends when you're butt fusing. We got to clear away that oxidative layer that was created by it being in the sunlight, and get rid of that contaminant before we slide on our electrofusion fitting. So we can make a proper fuse, because the only thing we want in there is polyethylene material, both from the fitting and from the pipe itself.
So we're doing the same thing with all of this, with treating HDPE, when we get back to that virgin resin material, and we're heating it to appropriate temperature, whether or not it's butt fusion, electrofusion, extrusion, any type of fusion that we're looking at, we're getting to that virgin resin material and allowing those molecules to go across that surface. There's a little bit more operator, intense stuff for electrofusion in this function, but once you're properly trained, it's just as simple as all fusion itself.
And this slide just shows kind of the anatomy of an electrofusion coupling. There's two zones. You're fusing two different pipes together with a coupling. You have 3 cold zones and 2 hot zones. The cold zones are there to allow, once the material becomes molten in that section where the wires are, we don't want that molten material to flow outside of the coupling. So once that molten polyethylene material hits that cold zone, it starts to dam up and create pressure to allow the materials to mix between the coupling and the pipe. I like the best analogy I can think of, if you can imagine the Hawaiian Islands when a lava flow happens, how that leading edge of the lava kind of curls back a little bit. That's what happens in the cold zone. And then that eventually stops, and then it builds up pressure, and that allows the materials to mix and create a fusion. So we're not really melting it, we're fusing it. This shows this is a good example of the new peeling tools. That's a chain scraper that's peeling that very thin layer off of the outside of the pipe, just creating those ribbons to get down to virgin material that's untouched by sunlight and dirt and other things like that. And then on the right, we have like a smaller sized peeler. Not sure if there's audio with this.
There is. I muted it. I didn't know if you wanted to just talk over it. Eric, did you have something that you wanted to contribute there?
I was going to talk to that further on the minute. A lot of times, in the process of adopting HDPE, there's that learning stage of the appropriate ways to do things and making sure that the people doing it are certified and know what they're doing. And one of the most important parts of either butt fusion or electrofusion is the preparation. Especially with electrofusion, the preparation on the piping and on the couplings is very important. Making sure you have a clean surface that you're working with, making sure, like you said, you get to the virgin material and have enough of the exterior of the piping peeled out for the electrofusion couplings to come in contact with. And just making sure that your site is appropriately prepared for that is a huge thing, but it can be a huge help in scenarios where you're having to align piping that you don't have a lot of give, or when you're in tight spacings to be able to connect up. Electrofusion can be a solution where you can't necessarily get a machine in there, and that's typically the areas in which we try to recommend, using the electrofusion in compact areas.
And that's a great point, Eric. That mention of training and certified trained, that you only want people that have gone through the training. It's not that hard. Like I like to say, I'm qualified to teach this stuff, so it can't be that hard. But but you do need to be trained, and it's every 2 years, because we know people pick up bad habits. But like I say, it's a very easy process, but you as a designer, an inspector, or whoever you are, you want to make sure that the people doing the job are qualified to do it.
And
That'll
now
ensure a good project.
this tool looks like it's pretty intuitive, and a lot of the designers of the tooling have thought through some of the efficiencies for us here as well. So, I mean, he's just popping that on and going right through it, but we still need to maintain and understand the principles of why we're doing this type of work, and that's part of that training process itself. So,
20 years ago, a paint scraper was okay to use, and it's no longer okay to use because the tooling has gotten up to speed, for sure. This is just a little example of a tapping tee that's electrofused on. You can see there on the left that they scraped it, or peeled it, and then on the right they're showing using the T-handle wrench to actually turn the cutter so that the tap machine is built into this fitting. They just take off that cap, put that T-wrench on there, and screw it down into the pipe. The cookie threads into the brass or stainless steel cutter, and then when you back it back out, the water turns on. So it's a really slick system, and like I say, there are millions and millions of these in utility systems in the United States, and they're on the gas side, on the gas distribution side. So if
So,
anybody ever says we don't want to be the guinea pig, they're not the guinea pig. The gas
oh,
industry has well vetted this product.
absolutely. So this is called live tapping. So that is the water in the pipe doesn't shut off, so that way we don't impact all the residents as we're putting in a new service, and we're simply doing that. So we've been reminded we've got to move along pretty quickly. So let's keep pushing through. So what we're seeing here now is tracer wire. So high density polyethylene in any plastic pipe does not convey electrical signal. So we need different things to be able to locate this pipe. And here we have an RFID ball that sends a signal to the surface, tells us exactly how deep and what type of pipe we're locating there, but then we're also pulling tracer wire, which conducts that electrical stimulus as we're coming through, and we put that through this process as well.
And not ironically, that tracer wire, today's modern tracer wire, is no longer that THHN, which is, meant for electric, in your house. It is actually has a HDPE jacket on the outside. And the reason for that is because it's so durable and good for underground installation.
Absolutely. Let's use it for that and use it for the main lines as we go through. And as Steve has said, that there's so many different types of fittings, and these are just examples of those types of fittings that you can have available to you. Anything that you have a preference for, it certainly works in that manner. We do work with compression fittings as well. So these are all rated to 150 psi as we're looking to put a compression fitting through this. This is often used for temporary service above ground or just that small service line as we come through there. And all those other fittings that we've showed you as well also have threaded capacities to be able to work with your favorite brass fitting as we come through. So here's a material handling guide for you. In 2018, PPI issued this as well. And Steve, I'd have to say that the video on the right is not necessarily the way that we should be handling this pipe material, correct?
I like to say just because you can handle it this way doesn't mean that you should. So polyethylene is just so durable. You can drop it and it doesn't break. You can bend it and it doesn't break. But just because, and there's a slide on it later on bend radius, just because you can bend it a lot doesn't mean you want to, because you're storing a lot of energy. And just because you can take a backhoe and knock it off the back of a truck when you're out at a quarry, that doesn't mean you should, because that's obviously a dangerous operation there. So the industry, PPI, came up with proper pipe handling guides, which if you're designing an HDPE project for waterworks, the waterworks world, I would suggest you refer to it, because it's just, it's longer pipe, it's more flexible. There are some considerations that are different. Beyond that, the nice part for us as a distributor is that when we have material in our yard, all our pipe for the water industry is black, and the reason for that is it's basically sunscreen. They put in carbon black, 2% carbon black, into the pipe material, mix it in with the resin to protect it from sunlight, and all that carbon black does is convert that UV energy that's hitting the pipe into heat, so it dissipates it into heat rather than destroying the molecules of the pipe. So if you had, I think there's some slides ahead that show other products that are susceptible to UV degradation. So we got to be careful on cycling those products out of certainly our distribution yard. We would never have anything like that in our pipe yards, but that's just pipe that sat in a municipality's yard for years and just got damaged from UV light. The gas industry protects their pipe, their yellow pipe, they cycle it through and manage their inventory to make sure that it gets in the ground within 2 years of it being manufactured. But that's not the case with polyethylene, with black HDPE. It's protected from the sunlight for it's for a lifetime. You can operate it above ground, like in those quarries and things like that, for a lifetime because it has the carbon black. Over the years, McElroy, the main manufacturer of HDPE fusion equipment, has developed many tools. The Trackstar there, helps with productivity. The hydraulic clamps that clamp it down help with operator fatigue, and then roller systems to get things loaded so you don't have a bunch of extra equipment on these medium-sized jobs having to load pipe into the machine each time. So these productivity tools have really developed a lot over the 25 years I've been in this industry. They've really taken a big step forward, and so has the sizes of the products, the fusion equipment, because the pipe manufacturers have gone to these massive sizes and thick walls because of advancements in the resin, quite honestly, where they have these new low slump resins that don't sag to the bottom as they're being extruded, so they can make very consistent walls with thick diameters. So polyethylene's getting into the larger and larger sizes because of these tools and the technology advancements over the years.
Yeah.
So butt fusion is the most common way that we join HDPE. The reason we butt fuse it is because we can't chemically bind it, and because it's so resistant to any kind of solvent welding chemicals like PVC. PVC can be solvent welded, but polyethylene can't. That glue would just flick off after it dried. And then polyethylene is so flexible that we can't really create a bell and spigot system because its durometer is close to that of the gasket. So we butt fuse it together. We create a leak-free system using heat and pressure and making a butt fusion, and that is the most common way to join the pipe.
So we had a great question here, which is after fusion, how long do we have to wait before we start to move that pipe material? So there's two parameters that we're looking at. There's a rough handling parameter, which is waiting until it's fully cool to be able to move that around, and that's going to be your installations via HDD or pipe bursting. And then there's also a just cool parameter as to which we can move that pipe and then fuse up the next run. That varies based on the DR and the size of the pipe. So McElroy has what's called the McCalc app, which will tell you everything. There's an app for that. So it'll tell you everything that you need to know as far as when you can do rough handling or safe handling through this pipe itself. But typically for the very large pipe, that 54-inch, that 60-inch, that is going to be a real thing that we look at for productivity for the person that's fusing that pipe. So the actual process of fusing could take a half hour, 45 minutes to be able to heat it up and then cool it down in that process. So great question. I'm glad you guys are thinking about it in that way. We have about 17 minutes left now, Steve. So we're going to still keep trying to move through as quickly as we can.
Yeah, so the bend radius of polyethylene, these are the rules of thumb. If you standard like a DR11 is 25 times the diameter. So that means you can bend a 12-inch pipe, which is that 13.2, into a 28-foot radius circle, or you could make a 90 in 44 lineal feet of pipe. So that gives you an idea how much you can really bend this pipe. So the only risk to the pipe is that if you bend it more than that, it would kink. It wouldn't break. It would kink like a hose. So that's the flexibility of polyethylene. It cuts very easily. We use a chainsaw or a saw. It's just basically anything that'll cut wood well will cut polyethylene well. We typically recommend a chainsaw without bar oil in it because we don't want that bar oil to become a contaminant during the fusion process. But it's very easy to cut for fittings or connections. Really easy to work with, and these examples show how we can bend it right around a corner, and you tend to have it, you don't want it scratching on something and making a gouge, so you bend it around something soft. such as that. But it's really, it takes a little bit of getting used to at first, but as soon as contractors learn the nature of it, they're very good at figuring out how to handle it. Over the years, field fusions have been developed so we can do almost any size in ditch in very tight spaces. The only caveat to an in ditch butt fusion is one of those pipes has to be able to move about 6 to 8 inches, depending on the size of the fusion machine. But all these things have been developed over the years and have created opportunities to do things that we couldn't do 30 years ago. We can just probably go to the next one. Yeah, so there's the poly horse that stacks the pipe before the fusion machine, so the one-man operation can load, and with the other end, they're pulling out the stringer, so they typically fuse together 500-foot stringers if you have the space, and then you can just have an excavator opening up the trench and roping it in once it's fully cool. And back to Alan's point or question earlier, the rule on cooling time is 7 minutes per inch of wall thickness. So if you have a 1-inch thick wall, you have a minimum cool time before when you pull it out of the machine would be 7 minutes. Just like other projects, you want to flush it and do your bacteria test. Running a poly pig through the line is a great way to clean it out. It's a very effective way to clean it out. These are the things you want to consider adding to your spec if you design a HDPE job. That's a great video that shows how the clean water comes right behind it and cleans out a new water line before you put it in service. And then pressure testing or leak testing is very similar to other products, other piping products, but we suggest you reference this leak testing spec because there are different, slightly different things about polyethylene. It's a leak-free system, but it does, you do have to add makeup water when you're getting the pipe to relax into that pressure that you're testing at. So this procedure allows for that and is the best procedure for leak testing HDPE. It only has slight variances from your other leak testing specs. This is testing the pipe before it even goes into the ground. So again, when you're above ground, the pipe behaves differently because temperature changes, the pipeline grows and shrinks. So you just need to make provisions for that when you're doing pre-chlorinated testing. And this is pipe being tested before it gets installed via pipe bursting or slip lining.
So oftentimes, what we're seeing is thermal effects will expand that pipe, so it'll grow in OD, but it'll also lengthen in its length as well. So that expansion allows for additional water to go through. While that's not a leaky pipe, we do allow additional makeup water. So what we do for nuance in the field basically is to pressure test in the morning if we're in a hot environment, especially Florida. Like some of the areas that we see here as well. So those types of things are understood once we start to know the pipe material, and it's just nuance to be able to come through and push everything in that manner as well. We've had some great questions about repair. So here's just basically an MAB guideline for repair itself. You would fix this like you would do everything else. They do have fittings that you can throw in the back of the truck because our water main break doesn't happen on a 9 a.m. on a Tuesday after we're done with our coffee. It happens at 2 a.m. on Christmas morning or something of that nature. And you can just put that repair clamp around the pipe just like you would any metallic pipe through that process. Whether or not that is a permanent repair is based on the fittings manufacturer and what they say about that particular repair through it. But the MAB does offer us a decision matrix, so to speak, about how we're going to go through and look at these repair options to be able to give us the best possibility for it. So here's just some more pictures on that in-ditch butt fusion. These trenches are excavated to provide safe working space for the employees working with the pipe. The actual trench width is not totally dependent upon the pipe diameter itself. It's basically for safe working areas for the pipe as we look through. But all of the machines are designed to be able to take off at the chassis and then be able to be lowered into the excavation to perform either that butt fusion or, in this scenario, that electrofusion that we're looking at. So there is no excuse for a contractor to not be able to perform a repair or perform an installation. All of this equipment really is set up in order to be able to do so. And we're going to look at two projects now in Fort Lauderdale who became somewhat of an approval or champion of HDPE pipe through their process, the Prospect Lake, and an emergency project through this process. Prospect Lake happens to be a treated water, so they're treating it at a wastewater treatment plant and then conveying it to another location for further treating. And that's a brand new project. And the emergency project happens to be a result of failure for crossing the intercoastal. A pipeline of force main was releasing raw sewage into the intercoastals. We hate those stories just because of everybody's impact through that process. But I will say HDPE saved the day in some of these process. And a lot of the things that we've talked about so far, trenchless installations, flexibility, durability, the ability to be able to use unique new installation methods for pipe procedure, such as compressive fit lining, are the reasons why this pipe really rose to the occasion to be able to look at it here. So Fort Lauderdale suffered through some pretty significant failure, as I had talked about briefly there, but they've selected HDPE to be able to take water from a wastewater treatment facility all the way to a brand new water treatment facility for further polishing of that water. So they're treating it in one place as wastewater, they're bringing it to another facility to be able to convey and get it to the location that they needed. HDPE was used because a lot of trenchless was used to be able to provide it. Fort Lauderdale is a developed suburban and urban area with lots of above ground construction that's been built through this process. And then they chose to be able to use that trenchless methodology to be able to install it. It's a 54-inch DR11 through this process. So it is a fairly large pipe. Steve had talked about low slump resins. That low slump is pushing us in a limit to be able to give us a much thicker wall pipe with the even diameters and the even parameters that we're really looking for to be able to give us a thick wall, large diameter, a large DR rating type of pipe through this process. So it is installed quite a bit on this project, as we've seen here, and Fort Lauderdale was very committed to HDPE through this process and the things that they've learned over the years. 50 MGD of high quality potable water, so they're turning in through multiple treatment processes to be able to give us a brand new water source. In lots of areas throughout the country when we're suffering significant drought, this is huge. This is exactly what we need to be able to turn around and give us a new water source through that process. 180,000 residents are supported by that 50 MGD. And then also we're using multiple trenchless technology methods to be able to install this pipe through what we're seeing here. So here's an example of that fused run. They're using all those productivity tools that Steve talked about to be able to fuse this long run up, to be able to make sure that we've got it in a manner as to which we can pull it in through trenchless installation. We're going to move it from this laydown yard to exactly where we want to go. Some of you out there have had questions about what's the longest run that we can use without some type of valve or other connection, and that shows you that the world is limitless here in this manner. This shows you the wall thickness that we're looking at for this pipe, and then also there are tools for you to be able to fuse this pipe together, as you're seeing here on the left. So there is equipment to be able to do this as we stage up and we get into much bigger pipe. The logistics behind it are larger, but the fusion process, the parameters, the thinking are all really the same in that manner through this process. And you can see here that this tool effectively is working with the equipment that we have on site to be able to pull that pipe out of the fusion zone and be able to load up the next pipe to be able to be fused in that run as we go through. That 7 minutes per inch is what Steve is telling you about the wall thickness, to be able to make sure that we're putting the appropriate amount of time and the appropriate amount of cool down time afterwards as well. And we're simply bringing this through. Fort Lauderdale, as I mentioned, is a developed suburban and urban area. So when we looked at this emergency force main project, we now have all of this residential place that happens to have gorgeous views on the water, that now has all this raw sewage that was released, unfortunately. So the project did certainly make the news as we're looking through. In 2020, they had several catastrophic breaks. A project like this has to happen very quickly, so they did bring a design build team together to be able to make sure that they could get to the fix that they needed as well. It did make the news. Typically, that's going to be one of those big drivers for us to be able to spend a whole lot of money repairing our infrastructures. We see that and a consent decree are those things that really elevate what we're doing pretty quickly in that manner. 54-inch and 40-inch, 48-inch pipe through this, 38,000 linear feet, 17 different HDD. So we had a lot of brilliant HDD engineers and contractors willing to take that risk to be able to install this pipe through the areas to which you've seen it. Very long project to be able to replace this. As all of this was ongoing and we still had emergency happening, we had vac trucks, vacuum excavation trucks going from one side of the canal all the way to the other side of the canal by moving that material back and forth, because we had no ability to cross the intercoastal in these areas to make sure that we could provide the force main material that we wanted through this. Trenchless was the savior of the day, as well as HDPE through this process as well. And then there's lots of different things that happened through our manufacturers of the pipe material, our distributors of the pipe material, to be able to help develop fittings like what you're seeing here as well. These are fabricated fittings to be able to make sure that you get across this very specific profile that you needed through this process. Please remember, everybody, to fill out the survey at the end. And then also, that's the easiest way to be able to get the CEUs as we're going through this. And we're trying to move pretty quickly at the very end to be able to release you from the webinar. Thank you very much for your attendance as we see it. So this unique crossing here actually was fabricated and then lowered down into the bottom of the canal that we're looking at there. So it did have terminal connections on either side. It was put down into the bottom of the canal to avoid a horizontal directional drill across this area. And these are fittings that are fabricated. So Core and Main, Milford, they can fabricate those for you in their yard in that manner as well. So Taylor, if you're still around and you want to come on, give us a couple of last words. Steve and Eric, I closed out pretty quickly here for all the things that we had going on. I really appreciate you guys sharing your expertise with us in that manner. And certainly we've got a couple of minutes for closing arguments here, fellas.
Right. I just think these pictures and these massive projects are so intriguing, and I love the problem solving that goes into it. Our industry has just grown by leaps and bounds by tackling such complicated projects such as these. I've had great experiences 10 years ago with chilled water projects, for universities and things like that. And that's how we learn, and that's how we grow as an industry. So it's just neat to see these large projects coming to fruition, and polyethylene pipe being the material of choice. And it'll be there for hundreds of years, and they won't have those future catastrophic problems that they're dealing with now. So it's exciting for the industry. And thanks everyone for taking the time, and hopefully you feel like you learned something today.
We had a comment about the survey for the last webinar. Unfortunately, the last webinar that the Alliance had at the close of it, that's when that big hack happened. And there were some 70,000 people trying to access Zoom that couldn't because of the hacking of Zoom. I'm not sure why you would want to do that, but that's what happened. So this one, hopefully there's no hack that's ongoing right now. You should be able to see the survey just fine. So we certainly appreciate it. And we had another question real quick from Hector about bringing road shows abroad. The Alliance for PE Pipe is actually looking to Argentina right now to be able to set up an alliance for PE Pipe in Argentina. So we're going to ship Eric down there right away because he loves steak and he loves to be able to go down and talk to Argentinians about high density polyethylene. I can't think of anybody better than Eric to be able to provide us that source.
Yeah, I can get there from Ohio too. So, I realize Houston's closer. I get it.
Any closing arguments, Eric?
That's perfect, Alan. That's exactly what I'm saying. I will go anywhere and everywhere to do whatever to help people develop and adopt HDPE. And I think I speak for everybody on this call, Steve, myself, and obviously PE. We're here as resources. There's a lot of opportunities out there to adopt this into your systems and do it the right way. There's a lot of things that we can still help and bring and help you design a project. Don't be afraid to reach out and ask questions. That's what we're here for, and that's why we do these webinars.
Awesome. Thank you all very much. We really appreciate your attention and go out and build some projects. We all want to see that. Thank you very much.
We're here to help.